transformation of a chemical substance into another chemical substance is known as a chemical reaction. You can represent a chemical reaction using symbols and formulas of substances, and such a representation is called as a chemical equation. Let's take a general example. A plus B giving C plus D. Here A and B are called as the reactants, C and D are called as the products, and the arrow which represents the chemical equation is the direction of the chemical reaction. You can make chemical reactions more informative by writing the symbols of physical states of substances in a chemical reaction. That is, if the reactants or products are in the gaseous state, you can use the small symbol G. If it is in the liquid state, you can use the symbol small l. If in solid state, you can use the symbol S, and if in aqueous state, you can use the symbol AQ. So thereby making the equation more informative. Also, you can write the condition in which the reaction is taking place. The condition is generally written above or below the arrow of the chemical equation. For example, if the reaction is taking place in presence of sunlight, you can write sunlight on top of the arrow or below the arrow to make the equation more informative. Let's see an example. When magnesium burns in air, that is, it reacts with oxygen to form magnesium oxide, the magnesium is present in the solid state, so it's given a symbol S. Oxygen is present in the gaseous state, so it's got the symbol G, whereas the product that is being formed is in the solid state again, so it's given the symbol S. And you see a triangle on top of the arrow, which indicates that the reaction is taking place under heat conditions. According to the law of conservation of mass, mass can neither be created nor be destroyed in a chemical reaction. So to obey this law, the total mass of elements present in the reactants must be equal to the total mass of elements present in the products. For example, when zinc reacts with sulfuric acid, that is zinc plus H2SO4 giving ZnSO4 plus H2, in this equation the number of zinc, hydrogen, sulfur and oxygen are equal on both sides. So this is a balanced chemical equation which follows the law of conservation of mass. So what is an unbalanced equation which does not obey the law of conservation of mass? For example, you react hydrogen with chlorine to form hydrogen chloride. Here, as you can see, there are two hydrogen atoms on the LHS but just one hydrogen atom on the RHS. Same is the case with chlorine. So what do? You have to balance this equation in order to obey the law of conservation of mass. So we can multiply 2 on the right hand side so as to get equal number of hydrogens and chlorines on both sides. Now how do we balance a chemical equation? You just have to follow the 4 simple steps. First of all, let's take an unbalanced equation which is Fe plus H2O giving Fe3O4 plus H2. Now step number 1 of balancing is to list the number of atoms of different elements present in the unbalanced equation. Here we have Fe, hydrogen and oxygen. So we are going to note down the total number of atoms of all these elements on the reactant and the product side. Step number 2 is to balance the atom which is present in maximum number. In this equation, oxygen is present in maximum number as you can see. So I am going to balance oxygen first. On the right hand side, there are 4 oxygen atoms, whereas on the reactant side, there is just 1 oxygen atom. So what do? We are going to multiply with 4 on the LHS, that is in front of H2O, so as to get 4 oxygen atoms on the reactant as well as the product side. A very important point that you need to note here is that you cannot add or subtract numbers in front of these molecules in order to balance an equation. You can only multiply with numbers to balance the equation. So now the equation becomes Fe plus 4H2O giving Fe3O4 plus H2. Now step number 3 is to balance the remaining atoms. Next I am going to balance hydrogen atom. As you can see, hydrogen on the left hand side there are 8 atoms, whereas on the right hand side there is just 2 atoms. So what can we do? I'm going to multiply with 4 on the right hand side, that is in front of H2, so as to get 8 atoms both on the LHS and the RHS, and the equation becomes Fe plus 4H2O giving Fe3O4 plus 4H2. Now you just have one element to be balanced, which is Fe. Fe on the LHS is just 1 atom, whereas on the RHS you have 3 atoms. So we are going to multiply with 3 on the LHS so as to get 3 equal atoms both on the LHS and the RHS, and the final equation becomes 3Fe plus 4H2O giving Fe3O4 plus 4H2. And the fourth step, which is the final step, is to check the correctness of the balanced equation. That is, you need to check if all the elements are equal on both sides. With that, we're done with balancing. Now to summarize, balancing of chemical equations is very important as per the law of conservation of mass. And you just have to follow the 4 simple steps to balance the chemical equation. Step number 1 is to list the number of atoms of different elements present in the unbalanced equation. Step number 2 is to balance the atom which contains the maximum number of atoms. Step number 3 is to balance the remaining atoms, and the final step is to check the correctness of the balanced equation.